Welcome back to Sleepy Orbits. Maybe the house has gone quiet, the lights are low, and the day is finally releasing its hold on you. You're in the right place. Tonight, we're going to watch the end of the world arrive, silently, invisibly, from a direction no one is looking. And I want to begin by taking something away from you, the thing you think you know about black holes. You think a black hole is a drain, a cosmic vacuum cleaner that sucks in everything around it. So when I say a black hole passes through the solar system, you picture us being pulled, screaming down some dark throat in the sky. Here is the truth. That is not what would happen. And the truth is so much worse. If you replaced our sun right now with a black hole of exactly the same mass, the Earth would not fall in. Nothing would. Our orbit wouldn't change by a single meter. We would circle that black hole in the dark on the same path for the same year, as calmly as we circle the sun tonight. Black holes do not suck. Gravity is gravity. From a distance, a black hole pulls no harder than any other object of the same mass. You've probably heard that a black hole would devour us. But here's the thing almost nobody understands. A black hole passing through our solar system wouldn't need to devour anything. It wouldn't need to touch the Earth, or catch it, or swallow it. It would only need to pass by. And gravity, ordinary gravity, the same force holding you gently in your bed right now, would do all the rest. It would reach across the empty dark, take hold of the planets, and pull the entire ancient, delicately balanced clockwork of the solar system apart, flinging worlds into the frozen void or down into the fire without ever coming close. And the most terrible part, the part we'll sit with tonight, is that we would almost certainly never see it coming. The first sign that the worst thing in the history of the Earth had already arrived would be the other planets, quietly, beginning to move wrong. By the end of tonight, the calm of the night sky is going to feel less like safety and more like luck. One thing before we begin. If you fall asleep partway through, good. That's the point. In the morning, tell me in the comments the last thing you remember hearing, and if you make it to the end, tell me which part of the passing black hole stayed with you and what you'd like us to explore next. If these nights help you rest, a like or a subscribe helps this channel more than you'd realize. Now, let's begin. Let's stay with that first strange fact a moment longer, because everything tonight grows out of it. The black hole does not suck. And once you really absorb that, the danger doesn't shrink. It changes shape into something far harder to escape. Here's why the vacuum cleaner idea is wrong. A black hole is not a hole in the ordinary sense, not an opening that things fall through. It's an object, a certain amount of mass crushed into an incredibly small space. And gravity only cares about two things: how much mass and how far away you are. It does not care whether that mass is spread out in a glowing star or crushed into a black hole the size of a city. 10 times the sun's mass pulls exactly like 10 times the sun's mass, black hole or not, at any given distance. The only reason a black hole is dangerous to get close to is that because all its mass is packed so small, you can get catastrophically close to all of it at once, closer than you ever could to a spread-out star whose surface stops you long before you reach its heart. But at solar system distances, millions, billions of kilometers, a passing black hole is simply a passing mass, a dark, silent, wandering weight. And a wandering weight is all it takes. Now here is the part that should raise the hair on your arms gently as you lie there. You would not see it approach. A star approaching the solar system we would spot for centuries, a new light brightening year by year, impossible to miss. But a black hole gives off no light, none. It is, by its very nature, the darkest object in existence, a place where even light cannot escape to announce it. A stellar mass black hole drifting toward us would be a circle of perfect black, moving against a background of black, lit by nothing, radiating nothing. It could be closer than the nearest star, and we would have no headline, no warning, no bright dot on any chart. It would come the way nothing else in the universe can come, completely unlit, completely silent, out of the one direction we can never watch, the dark itself. There is exactly one way it might betray itself before the gravity hits, and it is faint. As the black hole drifted in front of more distant stars, its gravity would bend their light, warping, brightening, and smearing the stars behind it like a lens made of pure gravity gliding across the sky. Astronomers have a name for this. They call it gravitational lensing, and it is real, and we have seen wandering black holes reveal themselves this way. But to catch it, you must be looking at exactly the right patch of sky, at exactly the right moment, and understand instantly what the flicker means. We might get lucky. We might get a few months' warning, enough to understand, not remotely enough to act. Or we might get nothing at all until the day an astronomer notices that Neptune is no longer quite where the mathematics says it should be. And on that day it is already far, far too late. Because by the time the planets move, the black hole is already inside the house. So that is the shape of tonight's nightmare, and it is a quiet one, no roar, no impact, no fire in the sky. Just a silent, invisible mass, drifting in from the dark, on a path no telescope caught, reaching out with nothing but gravity to touch every world at once. And the strangest thing of all, the thing that turns this from a horror story into something stranger and sadder, is that it is not really a story about a monster. The black hole is not hunting us. It feels nothing. wants nothing, aims at nothing. It is only falling through the galaxy the way everything falls, and we merely happen to be in the way. The most complete catastrophe imaginable, delivered without a trace of malice by an object that will never know we were here. Let's watch it come. Let's follow the whole encounter, slowly, from the first faint warning to the final silence, and begin where every disaster begins, with the fragile, beautiful thing that is about to be broken. Our solar system, as it is tonight, held together by a balance so delicate we have completely mistaken it for permanence. We think of the solar system as solid, permanent, a fixed arrangement of the sun and its planets, wheeling around in their orbits the way they always have and always will. The one thing in the sky you never have to worry about. It is the backdrop of every human life. The sun comes up, the seasons turn, the planets keep their appointments. Nothing about it feels fragile, but it is fragile, almost unbelievably so. And to feel why a passing black hole is so catastrophic, you have to first understand what the solar system actually is, because it is not a solid structure at all. It is a balance, a truce, a piece of clockwork so finely tuned that we have simply forgotten it could ever run wrong. Here is the truce. Every planet is, at every instant, falling. The Earth is falling toward the sun right now, pulled by the sun's gravity, exactly as an apple falls from a branch. The only reason it doesn't plunge in and burn is that it is also moving sideways, racing along its orbit at about 30 kilometers every second, fast enough that as it falls toward the sun, it keeps missing. It falls and moves sideways and falls and moves sideways, and the two motions balance so perfectly that the falling becomes a circle. That is what an orbit is. A fall that never lands because the ground keeps curving away. Every planet, every moon, every comet is doing this, perpetually falling, perpetually missing, held in a balance between the pull inward and the rush sideways that has kept them circling, stable, for 4.5 billion years. And that balance is exact. It depends on each planet having precisely the right speed for its distance, not too fast, or it would fly away, not too slow, or it would spiral in. Over billions of years, the solar system has settled into a set of orbits so well-tuned, so carefully spaced, that the planets barely disturb one another. It looks, from the outside, like a machine built by a master, gears meshing, each world in its lane, the whole thing humming along in silent, perfect equilibrium. We even use the word, the clockwork of the heavens. It kept such good time that for most of history, people set their calendars and their gods by it, certain it was the most reliable thing in all creation. But a clock is only as stable as the fact that nothing reaches in and grabs the gears, and the solar system's stability That 4.5 billion-year calm rests entirely on a single quiet assumption that has held for all of Earth's history, that nothing massive ever comes close enough to pull. The planets are tuned to the sun and to the sun alone. Add a second great mass, bring another heavy object anywhere near, and the tuning is meaningless. Every careful speed is suddenly the wrong speed because it was the right speed for a solar system with only one sun in it. The truce was written for one master. It has no terms for two. Sit with that for a moment, because the belief that the heavens are perfectly stable runs deep in us. It's one of the oldest and most beautiful mistakes in the history of thought. When Isaac Newton worked out the laws of gravity in the 1600s and showed that the same force pulling an apple to the ground also holds the moon in its orbit and the planets around the sun, it gave humanity a breathtaking new picture of the cosmos, the clockwork universe. A perfect machine, every part governed by exact mathematical law, running with the precision of a great celestial clock. A century later, the mathematician Pierre-Simon Laplace pushed the idea to its stunning conclusion. He imagined that an intellect who knew the position and motion of every particle in the universe could, using Newton's laws, calculate the entire future and the entire past with perfect certainty. The cosmos as a wound clock, its every tick foreordained, utterly predictable, utterly safe. For a long time, that was the dream of physics, and the planets were its proudest exhibit, the very image of order, permanence, and law. But the dream had a flaw hidden inside it, and it took another century to find. The clockwork is real, but it is not as stable as Laplace hoped, because the mathematics of gravity, once you have more than two bodies pulling on each other, does not produce clean, eternal, predictable motion. It produces something subtler and wilder, which we'll come to in a moment. For now, hold on to the image, because it's exactly the image a passing black hole would shatter, not just a solar system, but a 400-year-old faith that the heavens are a perfect machine that cannot break. This is the thing most people never grasp about orbits, and it's the key to the whole night. They are not held by strength. They are held by balance, and balance is the easiest thing in the universe to destroy. You do not need to overpower an orbiting planet. You do not need to grab it and haul it away. You only need to nudge it, change its speed a little, or bend its path a little at the wrong moment, and the delicate equality between falling and missing is broken, and once broken, it does not recover. A planet pushed a little too fast doesn't find a new stable circle. It climbs away on a path that carries it into the outer dark. A planet slowed a little too much doesn't settle. It begins the long fall inward. The clockwork has no way to heal itself. Knock it out of true, and it stays out of true. And the small nudge, given time, becomes a planet on a wildly different fate than the one it was born to. There's a deeper reason the clockwork is so fragile, and it's one of the quiet, unsettling truths of physics, worth knowing as you drift. We imagine the solar system is solved, that because we can predict eclipses centuries ahead and land probes on comets, the motion of the planets must be perfectly, permanently calculable. It very nearly is, but not quite. The mathematics of more than two objects pulling on each other at once, the sun and two planets, say, all tugging on one another, has no clean, exact solution. It's a famous problem, more than 3 centuries old, the three-body problem, and its lesson is humbling and worth carrying to sleep. Systems of many gravitating bodies are, in the deep mathematical sense, chaotic, meaning a tiny change in the starting conditions can grow over time into an enormous change in the outcome. Our solar system is stable enough to keep good time for billions of years, but it is not stable in the way a machine is stable. It is stable the way a spinning top is stable beautifully as long as nothing bumps it. The planets hold their lanes not because some law forbids them from leaving, but because, so far, nothing has pushed them hard enough, and the small pushes they give each other happen to average out. It is a balance maintained by luck and emptiness, not by any guarantee. And chaos cuts both ways. It's what makes the system fragile, but it's also what makes a black hole's nudge so devastating. Because in a chaotic system, a small disturbance doesn't stay small. Give the Earth one wrong shove, and the error doesn't fade away. It compounds, orbit after orbit, growing until a nudge that seemed survivable has become, centuries later, a planet on a wholly different and fatal path. The black hole wouldn't need to do the whole job at the moment of passing. It would only need to light the fuse, to introduce the one disturbance that chaos itself would then amplify patiently into ruin. In fact, and this is a genuinely unsettling thing that most people never hear, the solar system may not be perfectly stable, even without any outside interference at all. When astronomers run the equations of the planets forward on powerful computers, simulating billions of years of orbital motion, they find that the inner solar system is subtly chaotic on very long timescales. In a small fraction of those simulations, over the remaining lifetime of the Sun, the orbit of Mercury, the innermost planet, becomes so stretched and disturbed by the slow gravitational tugging of the other planets that it destabilizes entirely, and in the most extreme outcomes it can collide with Venus or the Sun, or even perturb the Earth. The odds are small, and the time scale is billions of years, so it is nothing to lose sleep over, but it tells you something profound about the ground you stand on. The clockwork is not wound to run forever. It carries, in its own mathematics, a faint, inherent instability, a tiny wildness at its heart. It has held so beautifully for so long, not because it is guaranteed to, but because chaos, most of the time, unfolds slowly. A passing black hole would simply take that latent wildness and unleash it all at once. Now you understand the weapon. A black hole passing through the solar system would not need to seize the Earth. It would only need to reach in and nudge to change, however slightly, the exquisite balance of speed and distance that keeps our world on its gentle ring. And a black hole of several times the sun's mass, sweeping through our neighborhood, would nudge everything at once, hard, in a way the clockwork was never built to survive. Let's watch it happen. Let's follow the encounter from the outside in. From the first faint tug at the fringes of the solar system to the moment the black hole crosses the orbits of the planets, to the silence afterward. And it begins, quietly, more than a light year away, in a place most people don't even know is part of the solar system at all. The black hole, let's say, is a modest one, a stellar mass black hole, the corpse of a single dead star, weighing perhaps 10 times the mass of our sun, crushed into a sphere you could tuck inside a city. Let that sink in for a moment. 10 times everything the sun is, its whole crushing weight, the mass that holds every planet in its grip, compressed into a dark ball, perhaps 60 kilometers across, small enough to sit unnoticed inside a modest city, and so heavy that light itself cannot climb off its surface. That is the object drifting toward us. This is by far the most common kind of black hole, and the kind most likely to wander. The galaxy is littered with them. It moves fast. Most stars and their remnants drift through the galaxy at speeds of tens to hundreds of kilometers every second relative to one another, so our intruder would be crossing the distance between the sun and the Earth in a matter of days, and sweeping through the whole realm of the planets in a few months to a year. This is not a slow siege. Once it reaches the planets, the core of the catastrophe plays out quickly, a season, perhaps, from the wrecking of the outer worlds to the black hole's closest approach and departure. It is not aimed at us. It is simply falling through the Milky Way on its own long orbit, as it has for billions of years, and its path happens by pure, indifferent chance to intersect the tiny patch of space we occupy. It has been coming for 100,000 years. We have known nothing. The first thing it reaches is not a planet, it is a shell of ghosts. To feel where that is, you have to let go of the usual picture of the solar system, the tidy diagram with the sun and 8 planets in their neat rings. That diagram is a lie of scale. The planets are the tiniest inner core of the sun's true domain, all of them huddled close to the fire, far beyond the outermost planet, far beyond even the fringe where the sun's wind finally peters out into interstellar space. The solar system continues outward and outward, for a distance so vast it dwarfs everything inside it. Wrapped around the whole thing like the shell around an egg is a colossal, faint, spherical cloud of frozen worldlets, trillions of comets, each a mountain of ancient ice, drifting in the deep and permanent cold so far from the sun that it hangs among them as merely the brightest star in their black sky. This is the Oort cloud, the true edge of the sun's realm, and it reaches perhaps a quarter of the way or more to the nearest other star. The planets you think of as the solar system are a tiny lit room at the center of a dark mansion that stretches almost to the neighbors, and the comets of that outer shell are bound to the sun by the thinnest thread of gravity imaginable. They are so far out and moving so slowly along their vast orbits, a single loop can take millions of years, that the faintest disturbance can set them loose. They hang at the very limit of the sun's grip, barely held the most delicate members of the whole solar family. And so they are the first to feel a stranger's pull. The black hole reaches them first. As it sweeps through the outer cloud, its gravity stirs the drifting comets like a hand passed through still water. Some are flung outward, lost forever to interstellar space, but others are knocked the other way, nudged out of their slow, safe orbits and sent falling inward, sunward. A slow rain of ice tipped loose from the edge of the solar system and dropped toward the worlds within. This is the first tremor, not a strike, a stirring thousands of years before the black hole itself arrives as the outermost, most delicate part of the solar system feels the intruder and begins quietly to come apart. If anyone were watching the skies of Earth in those millennia, they would see it only as a slow increase in comets, more and more of them, over centuries, blazing through the inner system. Beautiful, ominous, utterly misunderstood, most likely by whoever saw it. A rain of falling ice and no one guessing what had shaken the tree. Then the black hole crosses into the realm of the planets, and the encounter stops being gentle. It comes in silence and in darkness, exactly as we said, a moving circle of nothing, betrayed only, perhaps, by a faint warping of the stars behind it as its gravity bends their light. But now its pull is no longer a whisper. As it nears the outer planets, Neptune, Uranus, the ice giants on their wide, slow orbits, its gravity begins to compete with the sun's for possession of them. And this is the moment the tuning breaks. A planet like Neptune has circled the sun in the same serene ring for 4.5 billion years, held by a balance meant for one master. Now a second master arrives, 10 times the sun's mass, sweeping past. And Neptune, feeling that new and enormous pull, is yanked off its path. It might be flung outward, torn loose from the sun entirely and cast into interstellar space to wander forever in the dark. It might be whipped around the black hole and slung inward, on a new and violent path that crosses the orbits of the inner worlds. It might, if the geometry is cruel enough, be captured, pulled away from the sun to become a moon of the black hole itself, dragged off into the galaxy as a trophy. What it will almost certainly not do is stay. The outer solar system, in a matter of months, ceases to be a set of neat rings and becomes a scattering of worlds flung in every direction, the clockwork's outer gears stripped away and thrown to the dark. Then it reaches the giant planets themselves, Jupiter and Saturn, the great anchors of the outer solar system, each holding more mass than all the other planets combined. Even these are helpless. Jupiter has ruled its region of the solar system for 4.5 billion years. Its gravity so dominant that it shepherds asteroids and flings comets and holds a family of dozens of moons. But Jupiter is still only 1,000th of the Sun's mass. And against a black hole of 10 suns sweeping past, Jupiter is just another world to be moved. It could be torn from its orbit, its great retinue of moons scattered like a handful of thrown sand, the most powerful planet in the solar system reduced, in an afternoon, to just another piece of debris flung across the sky. And when Jupiter moves, it makes everything worse, because Jupiter's own gravity has helped hold the inner solar system in its delicate arrangement, and a Jupiter knocked loose becomes a second wrecking ball, its enormous mass now swinging through the system on a wild new path, disrupting whatever the black hole itself did not. And the black hole keeps coming. Past the asteroid belt, that ring of rocky rubble between Mars and Jupiter, the leftover bricks from which the planets were built. Normally the belt is stable, shepherded and spaced by Jupiter's steady gravity. But with Jupiter wrenched loose and a black hole sweeping through, the belt becomes a shotgun. Its asteroids, nudged from their careful orbits, are scattered inward on random crossing paths, a swarm of mountains loosed toward the inner worlds. Even if the Earth survived the black hole's gravity intact, it might not survive what the black hole threw at it, a bombardment of asteroids in the encounter's wake, any one of which could rival the impact that ended the age of the dinosaurs, arriving not singly across millions of years, but in a storm over centuries. The black hole would not even need to aim. It would only need to disturb the careful order that has kept the asteroids in their lane and let the wreckage rain where it fell. Inward then, toward Mars, the small cold world that might be flung from the system or dropped toward the sun or simply left on a ruined orbit, and inward still toward the small warm worlds at the heart of it all, toward Venus, toward Earth, toward us. Here is where the story stops being a single tale and becomes many, because what happens to the Earth depends entirely on one thing we have no control over: how close the black hole passes and from what direction. It is quite literally a roll of the dice, and the solar system is the table. Let's walk through what the dice can land on, from the gentlest catastrophe to the most complete, because every one of them is possible, and every one of them ends the world we know. Roll 1. The distant pass. Suppose the black hole never comes near the inner planets at all. It crosses through the outer system, wrecks the orbits of the giants, and continues on, passing no closer to the Sun than, say, the orbit of Jupiter. Earth is spared a direct encounter, and still it is not spared, because the gravity of a 10 solar mass object passing even that far away is enough to tug the Earth's orbit out of true, to stretch our gentle circle into an ellipse, or tilt it, or change its distance from the Sun. And here is the thing about the Earth that most people never appreciate. Our whole existence hangs on a razor's edge of distance from the Sun. There is a narrow band around any star. Astronomers call it the habitable zone, or, more fondly, the Goldilocks zone, where a world is neither too hot nor too cold, but just right for liquid water to exist on its surface. Too close, and the water boils away. Too far, and it freezes solid. That zone is not wide. The Earth sits comfortably within it, but comfortably means a margin measured in a modest fraction of our distance to the Sun. Nudge the Earth meaningfully inward or outward, and we cross the edge of the Goldilocks zone, and the water that makes this a living world either boils or freezes. Our orbit is not just a path, it is the reason there is anything alive here to walk that path. And it depends on that orbit being almost perfectly circular and almost exactly where it is. Pull us a little farther out, and the oceans freeze. A permanent ice age. The sun shrunk to a bright, cold point. The seas locked under kilometers of ice. Push us a little closer in, and the oceans boil away. Even a gentle pass, one that never comes near us, could shift the Earth into an orbit that ends all life on it, not with fire or impact, but with a few degrees of temperature, applied forever. The kindest roll of the dice still kills everything, slowly, by moving us a little nearer or a little farther from the warmth we were born to. Roll 2. The closer pass. Now, the black hole cuts through the inner solar system, passing near the orbits of Mars or Earth or Venus. Now the tug is not a gentle stretching, it is a violent wrench. The Earth could be flung inward on a plunging path toward the Sun, a few final years of a swelling, brightening sun growing day by day in the sky, the oceans steaming away, the last of everything ending in fire and light. Or, and this is the fate that haunts me most, flung the other way, torn from the sun's warmth entirely and cast into the outer dark, to become a rogue planet, a world with no star. Picture it, because it is one of the strangest things that could ever happen to our home. The Earth is not destroyed, it is not broken, It simply begins to fall away from the sun and never stops. Over the first months, the sun would visibly shrink in the sky, day by day, a little smaller, a little dimmer, the light going thin and grey. The world would begin to cool. First the tropics would chill, then the temperate lands would freeze, the rains would turn to snow, and the snow would stop melting. Within a year or two, the oceans would freeze over from the surface down, then finally solid. The sky would go black and stay black. No sunrise, only the stars wheeling over a frozen world. Eventually it would grow so cold that the air itself, the nitrogen and oxygen we breathe, would begin to freeze, snowing gently down out of the sky to lie on the ground as pale drifts until the atmosphere was gone and the earth was a bare, dark, silent ball of ice and rock drifting between the stars. And it would keep drifting for the rest of time. The earth, intact, whole, still carrying its mountains and its dry ocean basins and the buried, frozen ruins of every city we ever built, sailing out into interstellar space. A tomb world lit by nothing, wandering the dark between the stars for billions of years, passing other suns from unimaginable distances, never warmed by any of them, not destroyed, just taken, lifted out of the light and set adrift in the endless cold. One more rogue world among the many the galaxy already holds. And there are many. For this has happened to other planets, around other stars more times than anyone can count. The dark between the stars is not empty. It is scattered with orphaned worlds. Ours could become one of them in a single passing. And here is a strange, small flicker of hope buried in that cold, because it is not entirely certain that such a world would be dead. On Earth today, deep beneath the surface, in the rock and the sediment and the water trapped kilometers down, there lives a vast, hidden biosphere of microbes that never see the sun at all. They live not on sunlight, but on the Earth's own inner heat, and on the slow chemistry of rock and water, an entire shadow ecosystem that does not care whether there is a sun in the sky. On a rogue Earth, flung into the dark, the surface would freeze and die. But the deep heat of the planet's core would not vanish overnight. It would fade over billions of years. And in the warm, dark, buried places, around the last geothermal vents, in the deep aquifers kept liquid by the Earth's own dwindling heat, those microbes might persist, oblivious, for an astonishingly long time, riding the frozen wanderer through the dark, a last quiet ember of earthly life carried between the stars. The surface world we know would be gone, but life, which is stubborn beyond all reason, might drift on in the deep for ages, in the dark, never knowing the sun had ever been lost, even taken, even frozen, even flung into the endless night. The earth might not go entirely silent. Role 3, the direct encounter, the rarest role and the most absolute. The black hole passes very close to the Earth itself, within a few million kilometers or nearer. Now, for the first time tonight, the black hole's true nature matters, not just its mass, but its terrible smallness. And to feel why, you have to understand the one way a black hole really is different from an ordinary star of the same weight. You can get close to all of its mass at once. Think about it. Our sun is huge and spread out. Its surface is nearly 700,000 kilometers from its center. You can never get closer to the sun's mass than that surface. Get near it, and it stops you, burns you, holds you at arm's length. But a 10 solar mass black hole packs the same kind of mass into a ball a few dozen kilometers across, which means you can fall far closer to all that mass than any star would ever let you. And gravity grows ferociously as you close in. At the surface of the sun, gravity is strong but survivable. A few dozen kilometers from a black hole holding 10 times the sun's mass, gravity is beyond anything the word can hold. And here's what that ferocity does to a world that passes too near. When you get close to a compact mass, gravity stops pulling on you evenly. It pulls harder on the near side of you than the far side, because the near side is closer, and closer means stronger. Normally, that difference is far too tiny to feel. It's what raises the ocean tides on Earth, a gentle inequality in the moon's pull across the width of our planet. But near a black hole, that same effect, astronomers call it tidal force, becomes monstrous because gravity is changing so violently over distance. A close enough pass would raise tides not just in the oceans, but in the solid rock of the Earth, flexing the whole planet, cracking the crust, unleashing every volcano at once, boiling the seas with the friction of the grinding stone. And closer still, the difference in pull between the near side of the Earth and the far side would grow greater than the force of gravity holding the planet together at all. At that point, the Earth simply comes apart. It is stretched, pulled into a long stream of rock and molten fire, the whole world drawn out into a glowing ribbon spiraling around the black hole as it passes. Physicists have a word for this stretching, this pulling apart by tides. Near black holes, they call it, half grimly and half fondly, spaghettification. The Earth would not fall in necessarily. It would be unmade in the passing, shredded by nothing more than the difference in gravity between one side of the world and the other, and left as a glowing ring of debris strung along the path where a planet used to be. And the moon, our quiet companion, would be lost in almost any of these. A body bound to the Earth by a thread far weaker than the one binding Earth to the sun, plucked away by the black hole's passing gravity and sent on its own separate path, so that a surviving Earth might find itself suddenly moonless, its tides gone still, its nights gone dark. One more piece of the familiar sky simply taken. Every relationship in the solar system, planet to sun, moon to planet, the whole nested set of gravitational bonds built up over billions of years is only as strong as the assumption that no greater mass comes near. Break that assumption, and every bond is up for renegotiation at once. And notice, in none of these does the Earth get sucked in. Even in the direct encounter, the danger isn't a drain. It's the tide, the stretch, the difference in pull. The black hole passes through and moves on, indifferent, and what's left behind is a solar system rearranged or ruined, planets flung to the dark or dropped into the fire, or torn to rings, or simply nudged a fatal few degrees off the paths that kept them alive. The intruder never slows. It has an entire galaxy still to fall through. It leaves the wreckage of 4.5 billion years of stability in its wake, and it does not look back, because it cannot, because there is nothing there that looks. And so far, we've been imagining the gentlest kind of visitor, a stellar mass black hole, the corpse of one dead star, 10 times the sun's weight. But black holes come in a staggering range of sizes, and the intruder need not be small, and the larger it is, the less the dice even matter. At the small end are the ones we've described, stellar black holes, a few to a few dozen times the sun's mass, born from single dying stars. These are the wanderers, the common ones, the plausible visitors, and everything tonight has assumed one of them. But the universe builds bigger, far bigger. At the centers of galaxies sit the supermassive black holes, millions to billions of times the sun's mass, objects we've explored on other nights. Our own galaxy has one at its heart, some 4 million solar masses, and it is 50,000 light-years away, which is exactly why it has never troubled us. Those giants do not wander, they anchor. The danger tonight was never one of them. But imagine, just for the scale of it, that the intruder were not a 10 solar mass stellar corpse, but something 100 times heavier, one of the middleweight black holes that may drift in some numbers through the galaxy. Then there would be no roll of the dice at all. It would not need to pass near the Earth, or near Jupiter, or near anything. Its gravity would seize the entire solar system from across a vast distance and simply carry it off, or tear it apart wholesale, planets and sun together. The whole family of worlds scattered in one motion like leaves in a gust. The larger the mass, the further its reach, and the less it matters where precisely it passes. For the small wanderer, geometry is everything. A near miss is survivable. A direct hit is not. For a large enough black hole, there is no near miss. There is only the encounter and the aftermath. This is part of why the small ones are, in a strange way, the more interesting threat. A supermassive black hole we would see coming from far off by the wreckage it made of the stars around it. And in any case, they do not roam. It is the small, dark, silent, wandering stellar black holes, 100 million of them threading the galaxy unlit, that could actually arrive unannounced. The monster in tonight's story is not the biggest one. It's the one small enough to hide and common enough to be real. But there is one version of the encounter where the invisible thing, just for a moment, becomes visible. Where the darkest object in the universe lights up brighter than anything in our sky. And it's worth seeing, because it's the one moment in all of this that would be terribly beautiful. For all of tonight, the black hole has been dark, silent, unlit, invisible. That has been its whole horror. But there is a circumstance in which it would blaze briefly, ferociously, and become the brightest thing anyone on Earth had ever seen. To understand it, we have to correct one more piece of the picture, because it's the key to the only warning the sky might ever give. We've said a black hole gives off no light, and that's true. The black hole itself emits nothing. But a black hole that is feeding is another matter entirely, and it is one of the brightest phenomena in the universe. Here is why. As the black hole moves through the solar system, it doesn't pass through empty space. It passes through the sun's domain, full of gas, dust, comets, the thin wind streaming off the sun, and, if it comes close enough, the outer atmosphere of the sun itself, or the shredded remains of a torn-apart world. All of that matter feels the black hole's gravity and falls toward it. But it doesn't fall straight in. It spirals, swirling around the black hole, faster and faster, forming a flattened, whirling disk of infalling material. And in that disk, the matter is crushed and sheared and heated by friction to unimaginable temperatures, millions of degrees, until it blazes, not with reflected light, but with its own fierce glow. X-rays, ultraviolet, a searing white light pouring out of the doomed matter in the final moments before it crosses the edge and vanishes forever. The disk itself is one of the most extreme structures in nature. The matter on its inner edge, just before it crosses the horizon forever, is whipped around the black hole at a large fraction of the speed of light, orbiting in the final instants of its existence. The friction and compression in that whirling ring heat it to temperatures no star's surface ever reaches, hundreds of thousands, even millions of degrees, so that it radiates not gentle, visible light, but fierce ultraviolet and X-rays, the signature of matter in its death throes. This is how we find distant black holes across the whole universe, not by seeing them, but by seeing the searing glow of what they are eating. A black hole at rest in empty space is invisible. A black hole with something to feed on is a lighthouse. This is the paradox we've touched on other nights, the darkest object in existence wrapped in the brightest light in existence at the moment it feeds. And if a black hole passed close to the sun, close enough to begin tearing gas from the sun's outer layers, or close enough to have swallowed a planet on the way in. Then, for a span of days or weeks, there would hang in Earth's sky a second sun, a brilliant, savage point of light, whiter and fiercer than the real sun, blazing with the death glow of matter falling into the dark. It would cast hard shadows at midnight. It would be visible in broad daylight, and it would be the most beautiful and most terrible sight in the history of the world, because everyone who saw it would be looking directly at the thing that was, at that very moment, pulling their planet off its path. There's a quiet irony in it. The one thing that might finally make the invisible killer visible, the glow of it feeding, is also the sign that it is already here, already among the planets, already too close. The light would be the warning and the sentence at once. By the time the black hole lit up in our sky, the gravitational damage would already be done. The orbits would already be broken. The encounter would already be underway. We would not see the monster approach. We would only at the very end see it eat. And then, days later, weeks later, the light would fade. The black hole would carry its stolen matter onward, the disk would thin and dim, and the second sun would gutter out, leaving the sky dark again. But it would not be the same sky. The planets would be scattered. The Earth would be on a new and fatal path, and the thing that did it would already be gone. Back into the dark it came from, silent and invisible once more, falling on through the galaxy toward whatever it will pass by next, in 100,000 or 1,000,000 years. Which leaves us with the only question that really matters, lying here in the safe dark of tonight. Everything we've described, could it actually happen? Is this a real danger or just a beautiful nightmare? And the answer is stranger and closer to home than you might want it to be. We've watched this from above, the cold physics of orbits and tides, the solar system seen like a diagram. But let's come down now, all the way down, and watch it the way it would actually be lived. From a garden, on an ordinary evening, on the surface of the earth. Because the strangest thing about the end of the world in this version is how quiet its beginning would be. Let's live through the whole encounter, slowly from the ground. It starts with comets. Years before anything else, decades perhaps, the sky grows slowly richer with them. Where once a great comet was a once-in-a-generation event, a thing your grandparents told stories about, now they come every year, every season, more and more of them drifting up out of the dark and unfurling their long pale tails across the night, 2 at once, then 3, then a sky in which there is always somewhere a comet hanging, pale, silent, beautiful. To the people living then, it would be a wonder. Children would grow up thinking a sky full of comets was simply how the sky looked. Painters would paint them, astronomers would be delighted, then puzzled, then slowly afraid. because there is no natural reason for so many comets to fall inward all at once, unless something far out beyond the planets, in the dark shell of ice at the very edge of the sun's reach, has reached in and stirred it. The comets are the tremor before the earthquake, the first faint touch of the intruder, felt at the fringe of the solar system and sent gently inward as a rain of falling ice. But you would not know that, standing in your garden looking up. You would only see an age of wandering stars, a sky grown strange and lovely, and think yourself lucky to live in such a time. The most beautiful skies in human history would be the warning no one could read. There is a bitter irony in the comets, and it reaches back through all of human history. For thousands of years, our ancestors watched the skies and dreaded exactly this: the arrival of comets. A comet, to nearly every ancient culture, was an omen, a sign of disaster, the death of kings, the coming of war or plague, a wound in the orderly heavens. We now know that was superstition. A comet is just a dirty snowball on a long orbit, harmless, beautiful, indifferent. Generations of astronomers work to free us from that old fear, to teach us that the comet blazing overhead means nothing, portends nothing, threatens nothing. And they were right. A comet is not an omen, but in this one scenario, the passing black hole, the ancient dread would, by the cruelest coincidence, come true. The comets really would be a warning, not because they carried any power themselves, but because their sudden multitude would be the first faint fingerprint of the invisible thing at the edge of the solar system, stirring the frozen cloud. After all those centuries of learning not to fear the comets, the one time it truly mattered, the sky full of them really would mean the end was coming. And we would have taught ourselves so thoroughly and so rightly to read them as harmless that we might be the last to understand. The omen our ancestors feared, arriving at last, in an age too wise to believe in omens. Then, for a while, nothing. The comets thin. The sky quiets, and in that quiet, the black hole crosses into the realm of the planets. And the first sign, the real sign, is not something you could ever see with your eyes. It is a number in an astronomer's notebook that has gone wrong. Neptune is not where it should be. Then Uranus. The outer planets, tracked for centuries with perfect precision, have begun, very slightly, then unmistakably, to drift off their predicted paths. There is no explaining it, except that something massive and invisible is out there among them, pulling. That is the moment the world would understand, all at once, what was coming. Not from a light in the sky, from the planets themselves, moving wrong, and there would be nothing at all that anyone could do. Now the sky begins to change in ways you can see, and it happens over months. The outer planets, if you could track them, are scattering, but they're too faint to watch with the eye. What you'd notice first is subtler and stranger, the stars themselves in one patch of sky beginning to shimmer and warp. A region where the constellations look very slightly wrong, smeared, doubled, trembling, as though seen through a flaw in glass. That is the black hole's gravity, bending the light of everything behind it, a lens of pure darkness gliding across the heavens. You could not see the thing itself. You could only see the hole it made in the stars, a blindness moving across the sky, swallowing constellations and giving them back distorted as it passed. And then, if the dice have fallen the cruelest way, the second sun ignites. One night, or one day, for it would be visible in broad daylight, a new point of light appears, and it is not a star. It is fierce and white and wrong. Over days it brightens and brightens until it is the most brilliant thing in the sky, a savage white star that does not twinkle and does not move like the others, casting hard double shadows at midnight, drowning the constellations, growing too bright to look at directly. It would be, without question, the most extraordinary sight in the history of the human eye. Every person on earth would go outside to see it. Some would think it a miracle, or a judgment, or a sign. And a few, the astronomers, the ones who understood, would know exactly what it was. The intruder, unmasked, at last, no longer invisible, blazing with the light of its own feeding, as it tore matter from the sun or swallowed the ruins of a planet. The darkest thing in the universe lit up at last, hanging in the sky like a second, crueler sun. And already, at that very moment, its unseen gravity pulling the whole world off the path it had held since before there were eyes to watch the sky at all. The people of Earth would gather in their streets and their gardens and their fields and look up together at the beautiful, terrible light. And it would be the last new thing many of them ever saw. What the final days would feel like depends on the roll of the dice. Perhaps the nights grow slowly, imperceptibly colder, year upon year, as the Earth is nudged into a wider, colder orbit. A chill that never breaks, winters that never fully leave, the sun in the sky growing a fraction smaller, a fraction weaker, until the seas begin to still under ice. Perhaps the opposite, a warmth that builds and builds, the summers growing cruel, the sun swelling in the sky as the earth falls slowly inward. Perhaps, if the pass is close and violent, something faster and more terrible. Tides moving through the solid earth, the ground itself flexing, every volcano waking at once, the sky red with ash and the seas heaving. Or perhaps the strangest ending of all, the earth flung outward, whole and intact, and the sun beginning over months to shrink, to dim, to recede, until one day the brightest thing in the sky is no longer the sun at all, and the Earth sails out into the endless dark, carrying its oceans and its mountains and everything that was ever built upon it, cooling, quieting, the last warmth bleeding away into a night that will never end. No fire, no impact, just the light growing smaller behind us, forever, as our world is taken out into the dark. And then, however it ends for the Earth, there is the after. The black hole is gone, back into the dark, indifferent, already falling on toward its next chance encounter, 1,000,000 years away. And what it leaves behind is a solar system that no longer exists in any recognizable form. The neat rings are gone. Some planets flung to interstellar space, some dropped into the sun, some tumbling on wild new ellipses that cross each other's paths, colliding or near missing for ages to come. The sun itself, perhaps, subtly shifted, its family scattered. If anyone returned to this solar system in 100,000 years, they would find a handful of surviving worlds on strange, lonely orbits, and a great deal of emptiness where planets used to be. The wreckage of a system slowly, over millions of years, settling into some new and impoverished balance. The clockwork would not stop entirely. Gravity would still rule whatever remained, but the particular, precious, life-bearing arrangement that took 4.5 billion years to build would be gone in an afternoon, and it would never come back. Some things, once broken, cannot reform. A solar system tuned for life is one of them. That is the view from the garden. And in every version of it, the thing that did it was silent and invisible, and never meant us any harm at all. Come back now. Come back to your own garden, your own safe night, the real sky over your real roof, because you have just imagined the worst thing that could happen, and now you get to hear why it almost certainly won't. It would be comforting to file all of this under fantasy, a thought experiment, a scary story, the kind of thing that could never really touch us. So let me take that comfort away gently, because the truth is more interesting. And you're safe in your bed, regardless. Wandering black holes are real. They are not hypothetical. The galaxy is full of them. To understand where they come from, you have to watch a star die. A star far more massive than our sun, say 20 or 30 times its mass, burns furiously through its fuel, and then at the end collapses. Its core, no longer able to hold itself up, falls inward in less than a second, and the outer layers crash down and rebound in a titanic explosion, a supernova briefly outshining an entire galaxy. And in the ruin at the center, if the collapsing core is heavy enough, gravity wins completely. The matter is crushed past every limit, past the density of an atomic nucleus, down and down until it vanishes behind an edge from which not even light can return. A black hole is born. A stellar mass black hole holding several times the sun's mass in a sphere a few dozen kilometers across, the compressed corpse of a giant star. That edge, by the way, the surface of a black hole, isn't a surface at all. It's a boundary in empty space called the event horizon. The distance from the crushed mass at which the pull becomes so strong that escape would require moving faster than light, which nothing can. Cross it, and there is no coming back, not for matter, not for light, not for any signal. That's all a black hole really is, a mass so concentrated that it has wrapped a one-way boundary around itself. Everything outside that boundary, which is where the entire encounter tonight takes place, behaves exactly like the gravity of any object of that mass, which is precisely why a passing black hole is a gravitational catastrophe, not a devouring one. Almost nothing ever actually reaches the horizon. It doesn't need to. And there is something worth pausing on in that boundary, because it is one of the strangest things in all of physics, and it makes a fine thing to drift toward. The event horizon of a 10 solar mass black hole is small, a sphere only about 60 kilometers across, a darkness you could drape over a city and its suburbs. Inside that boundary is not a solid object, not a surface, not a ball of super-dense matter. It is, as far as our physics can tell, mostly empty space with all the crushed mass gathered at a single unfathomable point at the very center. The horizon is just the line in the emptiness beyond which the falling never stops. And if you could somehow watch something fall toward it, a comet, a wisp of gas, a doomed spacecraft, you would never actually see it cross. As it approached the edge, its light would stretch redder and dimmer. Its motion would appear to slow, and it would seem to freeze, fading at the very brink, held there in your view forever, an image growing eternally fainter, but never quite winking out. The horizon keeps a ghost of everything that ever fell past it, painted on the dark, slowing toward an instant that, from the outside, never comes. That is the thing that would pass through our solar system, not a monster with a mouth, but a small, silent sphere of frozen light and empty space, wrapped around a point where the rules run out. And here is why so many of them wander alone. Every black hole made from a dying star begins its life inside a galaxy churning with motion, and many are born with a kick. The supernova that creates them is often lopsided, exploding a little harder on one side than the other, and that imbalance can fling the newborn black hole off through space at hundreds of kilometers per second, like a cannon firing its own barrel across the galaxy. Others are set adrift more slowly, flung out of their birth clusters by gravitational encounters, or left orbiting nothing when a companion star dies and drifts away. And so, across the Milky Way, there moves a vast, dark population of them, black holes belonging to no star, orbiting nothing, falling through the galaxy alone, unlit and unseen. How many? The estimates are staggering. Something like 100 million stellar mass black holes in our galaxy alone. 100 million dark, wandering masses, threading silently through the same galaxy we live in, and nearly every one of them completely invisible to us. A dark traffic moving through the bright one, unseen, uncounted, and, until very recently, entirely beyond our reach to find. For a long time, that was purely a calculation. We believed they were out there, but we had never actually caught one, precisely because they give off no light. And then in 2022, we caught the first. It was found the only way such a thing can be found, not by seeing it, but by watching it bend the light of a star behind it. Astronomers were monitoring millions of stars toward the crowded center of the galaxy, watching for the telltale flicker of gravitational lensing, that warping of background starlight we spoke about earlier. And one star, over many months, brightened and shifted in a very particular way, its light deflected by something massive and utterly dark passing in front of it. Using the Hubble Space Telescope, over 6 patient years, they measured the tiny deflection precisely enough to weigh the invisible object. It came out at around 7 times the mass of the Sun, a dark, compact, isolated mass, giving off no light of its own. A black hole wandering alone through the galaxy, betrayed only by the way it bent the light of a star it happened to drift in front of. The catalog name is a string of letters and numbers. What matters is what it represents. The first confirmed free-floating black hole, proof, at last, of the dark wanderers we had only inferred, one of 100 million, the single one we've managed to catch in the act of passing. And here is the fact that should make all of this feel suddenly uncomfortably real, because it's not black holes that have visited us, but their living cousins, the stars, and they have come closer, and more recently, than almost anyone realizes. 70,000 years ago, which in cosmic terms is essentially last week, there were human beings alive on Earth, our own ancestors, watching the sky. A star passed through the outer edge of our solar system. It's called Schultz's star, a small, dim red dwarf with an even fainter companion, and by tracing its motion backward, astronomers found that it swept within about 8/10 of a light year of the Sun, right through the outer Oort cloud, the shell of comets at the fringe of our domain. That is roughly 5 times closer than the nearest star sits today. Somewhere out in the dark cloud of comets, 70,000 years ago, a star drifted through, stirring the ice as it went, and on Earth, our ancestors would have seen it, if they looked, as an unremarkable faint red star there for a while, then slowly gone. They could not have known that a sun had just brushed the edge of their solar system. It was, by pure luck, small, and it passed through only the outermost fringe. But it happened during the human story. A star came through, and another is coming. A star called Gliese 710, a modest orange dwarf, is right now falling toward us on a path that will bring it, in about 1 1/3 million years, closer than any star in known history, passing perhaps 1/6 of a light year away, some 25 times nearer than the closest star today, plunging deep into the Oort cloud. It is not a danger to the Earth directly. It won't come near the planets, but it will pass close enough to shake the comet cloud hard, sending, astronomers estimate, a long rain of comets down into the inner solar system for millions of years afterward. We know its name. We know its mass. We know, roughly, when it will arrive. The strongest stellar encounter in the solar system's known future is already on the calendar. A star drifting in from the dark on a path we've measured, due in 1 million years. So stars pass through. It has happened within the lifetime of our species, and it will happen again on a schedule we can already read, and a wandering black hole is nothing more exotic than the corpse of a star, the same kind of object, drifting on the same kind of path, subject to the same slow galactic currents, except dark instead of bright and far harder to see coming. If a red dwarf can thread the Oort cloud during the age of humans, then the thing we've imagined tonight is not fantasy at all. It is simply the same ordinary event, a star passing through with the lights turned off. And it isn't only stars that visit. In the last few years, we've watched smaller wanderers come through the solar system from interstellar space, and they've given us a small taste of what a visitation feels like. In 2017, astronomers spotted an object tumbling through the inner solar system on a path that could only have come from another star. A strange, elongated fragment we named Oumuamua, a Hawaiian word meaning, roughly, a messenger from far away, arriving first. It was the first confirmed interstellar visitor ever seen, a shard of some other solar system drifting for who knows how many million years through the dark between the stars, threading by pure chance through hours, swinging around the sun and continuing on, never to return. A second such visitor, a comet from another star, was found soon after, and more have been spotted since. These are small things, harmless, mere rocks and ice, but they prove the essential point beyond any doubt. The solar system is not sealed. Things come in from the dark. The doors are open and objects from beyond do drift through our home on paths we cannot predict until they arrive. A wandering black hole would simply be the largest, darkest, and most consequential of these visitors, the same kind of trespass played for the highest possible stakes, which raises the question you're now, I suspect, quietly asking. If there are 100 million dark ones drifting through our galaxy, and even the bright ones pass through from time to time, could one be coming for us? To think about the odds properly, it helps to remember that we are not sitting still. The sun is not parked in the galaxy. It is falling around it, carrying all of us with it on a vast orbit that takes roughly 230 million years to complete a single loop around the galactic center. In all of Earth's history, the Sun has made only about 20 of those laps. And as it travels, it passes through different neighborhoods, sometimes through the crowded spiral arms where stars cluster thickly, sometimes through the emptier spaces between them. Our encounters with other stars and with the dark wanderers depend on where we are in that long journey. Right now, and for a long time to come, we drift through a relatively quiet, sparse stretch of the galaxy, which is part of our good fortune. But over the great sweep of time, the Sun's road winds on through denser regions, and the chances of a close pass rise and fall with the traffic. It's another reminder that our safety is not a fixed guarantee, but a slowly changing weather, and that, for now, the weather is calm. Here is the honest and genuinely comforting answer to whether one is coming for us. Almost certainly not for an unimaginably long time. And the reason is the one thing that has protected the Earth for 4.5 billion years and will protect it for billions more. Space is mind-annihilatingly empty. The distances between stars are so vast, and the black holes, though numerous, are so few compared to that emptiness, that the odds of one passing close enough to harm us in any given era are almost incalculably small. To feel how empty, try to hold the real scale for a moment, though the mind resists it, and that resistance is exactly the problem. If you shrank the Sun down to the size of a single grain of sand, then the nearest other star on that same scale would be another grain of sand, roughly 6 kilometers away. 6 kilometers between 2 grains of sand, and nearly all the space between them, nothing. No dust worth mentioning, no rocks, no light, but the thin rain of distant starlight. That is the true texture of the galaxy, not the crowded, glittering field the pictures suggest, but a few grains of sand scattered through an ocean of empty dark, kilometers apart, each alone. Now imagine 100 million black holes, each also a mote, drifting somewhere in that vastness. However many there are, the emptiness is so much vaster that the odds of any two motes finding each other in any stretch of time you could care about round down to nothing. The nearest known star is over 4 light years away. The space between us and it is, to all purposes, a perfect void. A wandering black hole would have to cross oceans of that emptiness and thread itself by pure chance through the tiny bright bubble of our solar system, a target almost invisibly small against the scale of the galaxy. It is like asking whether 2 specific dust motes set adrift in 2 different cities will happen to collide. Over the entire history of the Earth, through 4.5 billion years, it has never happened. The clockwork has run untouched since before there was life to keep time by it, And the same emptiness that makes the galaxy so lonely, the same vast, cold distances we sometimes find frightening when we look up, is exactly, precisely the thing that keeps us safe. How we found that one is a lovely piece of science, and it's the same faint signature that might one day give us our only warning. The technique is called gravitational microlensing, and it comes straight from Einstein. Mass, he showed, bends space itself, and light passing through bent space follows a curved path. So, a massive object passing in front of a distant star acts like a lens, bending and focusing the star's light, making it appear to brighten and shift position slightly over the weeks the alignment lasts. Crucially, this works even if the lensing object gives off no light at all. A black hole betrays itself not by shining, but by the way its gravity warps the light of a star behind it. Astronomers watch millions of stars night after night, waiting for one to brighten in the particular telltale way that means something massive and dark is drifting across it. That is how the wandering black hole of 2022 revealed itself, a distant star, brightening and shifting for months, its light bent by 7 solar masses of pure darkness gliding silently in front of it. And this same technique turns the fear, at least a little, into hope. We are getting better at seeing the dark. For most of history, a wandering black hole would have been utterly undetectable. It took the Hubble Space Telescope and 6 years of painstaking measurement to confirm the one we found. But the tools are improving fast. Enormous new survey telescopes designed to watch the entire visible sky over and over, catching every flicker of every star, and space observatories mapping the precise positions and motions of more than 1 billion stars at once. New survey telescopes are being built specifically to watch millions of stars at once, night after night, precisely to catch the faint gravitational flicker of dark objects passing in front of them. Space observatories are mapping the positions and motions of more than 1 billion stars with staggering precision, building a 3-dimensional chart of our galactic neighborhood. Slowly, patiently, we are learning to census the dark, to find the wanderers not by their light, which they don't have, but by their gravity, which they cannot hide. It's possible that within this century, we will have mapped the nearest of them and know for the first time whether any dark mass is drifting anywhere near our corner of the galaxy. For 4.5 billion years, the Earth has been blind to what moves in the dark around it. We are just now beginning to open our eyes. And that matters because a passing black hole is one of the very few cosmic catastrophes that a warning could not truly save us from. It's natural to ask, as you might be asking now, whether we could do anything if we saw one coming. Could we defend ourselves? And the honest answer is no, not in any way we can currently imagine. We can nudge a small asteroid off course, We cannot move a planet. Against an object of 10 solar masses reaching in with gravity to reshape the entire solar system, there is nothing to push against, nothing to deflect, nothing to shelter behind. The forces are simply too large, working on too vast a scale. If a black hole were on a collision course with the solar system's stability, we would be able to measure it and predict it and understand it in exquisite detail and do absolutely nothing to prevent it. But there is something profoundly human in the wish to at least know, to not be taken entirely by surprise, to have the dignity of understanding what is happening, even at an end you cannot change. Perhaps, with centuries of warning, there would be time to do the one thing our species has always done in the face of the unstoppable: to prepare, to record, to send something onward. To gather what we are and cast it outward, messages, seeds, knowledge, some arc of who we were, into the dark, ahead of the wave, so that even if the earth were lost, we were not entirely. That, too, is what the census of the dark is really about. Not defense, which is impossible, but foresight, which is not. The insistence on being a species that sees even the things that give off no light, even the things it cannot stop. But almost certainly not is not never. And that thin, honest gap between them is the thing to carry down into sleep tonight, not as a fear, but as a kind of wonder. Let's end where we began, with the calm of the night sky, but seeing it differently now. For all of human history, we have treated the stability of the heavens as the very definition of permanence. When we wanted a symbol for something eternal, something you could count on forever. We reached for the stars, the sun, the fixed turning of the sky. The motion of the planets was the most reliable thing we knew. So reliable we built our first sciences on it, our first gods, our first sense that the universe was orderly and safe. The clockwork of the heavens was, to our ancestors, the one thing that would never, ever break. And tonight, we've seen the truth beneath that ancient comfort. The clockwork is not eternal, and it is not guaranteed. It is a balance, a truce among falling worlds, tuned over billions of years, holding only because nothing has yet reached in to disturb it. Its stability is not a law of nature. It is a run of luck, an extraordinarily long, extraordinarily fortunate run, 4.5 billion years without a single close pass by any of the 100 million dark wanderers threading the galaxy. But luck all the same. We did not earn the calm of our sky. We inherited it the way you inherit good weather, as a gift that happens to be holding for now, with no promise attached. And there is a way to feel that not as fear, but as its opposite. Because if the peace of the solar system is luck rather than law, if it is fragile and unguaranteed, and could in principle be broken by a silent mass out of the dark, then every ordinary night is not a boring certainty. It is a small, ongoing miracle. The Earth held its orbit again today. The sun rose where it should. The planets kept their ancient appointments as they have 4.5 billion times before, through an emptiness full of things that could have ended it and simply, mercifully, didn't. The stability you've mistaken your whole life for granted is, seen truly, a streak of impossible good fortune still running, and you are alive inside it, on a world that kept its balance one more day. There's an old human tendency to want the universe to be safe, to be a place built for us, with guarantees, where the ground beneath our feet is promised to stay solid, and the sky is promised to stay put. Tonight offers a gentler and truer kind of comfort than that. The universe makes no promises. It never did. The solar system was not built to be safe. It simply happens, for now, to be. And that turns out to be enough, more than enough, because the calm we live inside is real, and it is holding, and the odds that anything disturbs it in all the long years of your life and your children's lives and their children's after them are so slim as to be, for every practical purpose, zero. You do not need a promise to be safe. You only need the emptiness of space, which is vast beyond fear, and the quiet luck of the clockwork, which has held since before the first living thing drew breath and holds still. The dark is full of wanderers. Most of them we will never see, and none of them, in any span of time that touches your life or your children's or your children's children's, is coming for us. The odds are on our side by margins too vast to fear, but the fact that it is odds and not certainty, that the calm is luck and not law, is precisely what makes it precious. Nothing you take for granted is guaranteed, which means nothing you take for granted is ordinary. Not even the quiet, ordinary sky over your roof tonight, holding steady as it has for longer than there have been eyes to watch it. Now, as we come to the end of tonight's journey, let's gather it all back together gently and let it settle. We began by taking away the thing you thought you knew, that a black hole is a drain, a devourer, a mouth in the dark. And we found something stranger and quieter in its place. A black hole does not suck. It does not hunt. It only falls through the galaxy, as everything falls, carrying its gravity with it. And if it ever passed near us, it would not need to catch the Earth to end it. It would only need to pass by and let gravity, ordinary gravity, unpick the delicate balance that keeps our world alive. We saw how fragile that balance truly is. Not a solid structure, but a truce, a spinning top, a piece of clockwork tuned for a single sun, and helpless before a second mass. We watched the encounter unfold, from the first stirring of the comet cloud, to the outer planets torn from their rings, to the roll of the dice that would decide the Earth's fate, frozen or burned, or flung into the dark, or stretched to a glowing ring by the difference in gravity across a single world. We saw the one moment the invisible killer would blaze, feeding a savage second sun in the sky, beautiful and final. And we stood in a garden and watched it come. And then we came home to the true sky, the safe one, and found the wanderers are real, 100 million of them threading the galaxy, one of them caught at last in 2022, bending the light of a distant star. Real and many, and almost certainly never coming for us, because space is so vast and so empty that 4.5 billion years have passed without a single close encounter, and billions more will likely pass the same way. They showed us that permanence is a story we tell ourselves, that the stillness of the sky is not eternity, but a balance. They showed us that the most complete catastrophe imaginable could arrive without malice, without warning, without a sound, carried by nothing but the gentlest force we know. And they showed us that the calm we take for granted was never guaranteed at all, that it is and has always been a long and lucky peace, still holding one more night, which is not, in the end, a frightening thought. It's a grateful one, because the sky over your house tonight is not boring, and it is not owed to you. It is a 4.5 billion year streak of good fortune, still running, the planet still turning, the sun still holding us close, the dark full of wanderers that have every single day of your life simply passed us by. And there's a deeper turn to that gratitude, worth resting on as you sink towards sleep, because the same indifferent universe that could, in principle, undo us is the very universe that made us in the first place. That black hole drifting somewhere in the dark, feeling nothing, aiming at nothing, is not an intruder from outside the natural order. It is our own kin. It was a star once, as our sun is a star, born from the same kind of collapsing cloud, burning by the same fusion and dying as all great stars die in the collapse that leaves a black hole behind. The atoms in your body, the calcium in your bones, the iron in your blood, the oxygen you are breathing right now, slowly, in the dark, were forged inside stars exactly like the one that became that black hole and scattered across space when those stars died and gathered up again into the sun and the earth and eventually into you. The very same processes that build wandering black holes are the processes that built the carbon that is, at this moment, thinking these thoughts. We are not separate from the dangerous universe, we are made of it. The dark that could end us is the dark we came out of. So when you look up tomorrow night or any night and find the sky calm and ordinary and safe, try to hold both things at once, because they are both true, and together they are one of the most beautiful facts there is. The universe is indifferent. It did not make itself gentle for us. It did not promise us tomorrow. It runs on physics that does not know our name and would not pause for it. And yet, out of that same blind, indifferent, occasionally catastrophic universe, here we are, warm and alive and safe tonight, on a world that has held its balance for longer than there have been eyes to watch the sky, gathered from the ashes of dead stars into something that can lie in the dark and wonder about the very objects that made it. The wanderers pass us by, the clockwork holds, the dead stars became us, and the enormous, silent, indifferent cosmos which owes us nothing and promises us nothing has, so far, and for all the years of your life still to come, let us be. That is not a small thing. That is very nearly everything. There's an old idea that the point of contemplating the vast and the catastrophic, the passing black hole, the death of stars, the enormous indifferent dark, is not to frighten ourselves but to shrink our troubles to their proper size. Lie here long enough with the true scale of things, and the worries that felt so heavy this evening begin gently to loosen their grip. The unpaid bill, the unkind word, the thing you said or didn't say, set against a universe of 100 million wandering black holes and 4.5 billion years of luck, they do not vanish, but they soften. They take their real place, small and human and survivable. This is the quiet gift the big dark gives us if we let it. Not despair, but perspective. Not fear, but a loosening. The same stars that could, in some unimaginable future, undo us are the ones that put our small nightly troubles back in proportion tonight. That is a fair trade. That is, perhaps, what the night sky was always for. Thank you for spending this night with the thing you cannot see coming, from a black hole that doesn't suck to a sky that holds steady against all the odds. If tonight's journey moved you or made the ordinary night outside your window feel a little more like a gift, take a moment whenever you surface to like the video and subscribe. It genuinely helps this quiet corner of space keep going. And now, let the fear go, because there's nothing to fear tonight. The clockwork is holding. The planets are keeping their appointments. The dark is far away and mostly empty. And the few silent things that wander it are, all of them, somewhere else. Above your roof right now, the sky is doing exactly what it has done every night of your life and every night of all the lives before you. Nothing at all, holding its ancient balance, keeping perfect time. The planets are out there in the dark this very moment, falling and missing, exactly as they have 4.5 billion times over, tracing their patient rings around a sun that holds them close and asks nothing in return. Somewhere far out beyond them, the frozen comets drift in their vast, slow orbits, undisturbed. And beyond even those, the dark stretches away, empty and enormous. And whatever wanders it tonight is so impossibly far from us that its indifference is a kind of mercy. A calm so old and so steady that we mistook it, forgivably, for something that could never end. Tonight, you know better. You know it is luck and balance and emptiness holding, and knowing that the calm becomes not less precious, but infinitely more. The safest thing about your night is also the most fragile, and it is holding, and it will hold, long past the morning, long past your whole life, long past everything you will ever need it to. Let the sky be tonight simply what it is: steady, silent, safe, and yours. Sleep well.